James Webb just found a pattern in space that should not exist. For thousands of years, humanity has stared into the night sky and tried to turn the darkness into a story. We named the stars, we measured the planets, we built equations, telescopes, observatories, and satellites, all because of one ancient question. What is the universe trying to show us? For a long time, we thought we were getting close to the answer. We believed galaxies formed slowly. We believed planets followed predictable rules. We believed space was mostly random on the largest scales, a cosmic ocean shaped by gravity, time, and chance. Then the James Webb Space Telescope opened its mirror toward the oldest light in existence, and the universe did something no one expected. It pushed back. What Webb has revealed is not just beautiful, it is uncomfortable. Galaxies appear too old. Worlds appear too massive. Rings of light curve with almost impossible symmetry.
Invisible masses bend space where nothing should be hiding. And across the deep field images, patterns begin to appear. Not once, not twice, but again and again. This is not simply another space discovery. It is a collision between the universe we modeled and the universe that actually exists. And if these observations mean what some researchers fear they might mean, then our understanding of time, matter, gravity, and even the beginning of everything may be incomplete. Maybe the universe is not as random as we thought. Maybe it has a structure we have barely begun to notice. Maybe the darkness is not empty at all. When James Webb began sending back its first deep field images, scientists expected surprises. That was the point. The telescope was built to see farther than Hubble, to look deeper into time, to reveal galaxies that were too faint and too ancient for earlier instruments. But the first problem was not distance, it was order. In image after image, Webb revealed galaxies and light structures arranged in ways that looked strangely organized. Some appeared connected by faint threads. Others seemed aligned across enormous distances. In certain fields, points of light formed patterns that were difficult to ignore. Of course, scientists are careful. The human brain loves patterns. We can see faces in clouds and meaning in shadows. A strange alignment in space does not automatically mean anything. But the problem was repetition. The farther Webb looked, the more the universe seemed to resist the idea of pure chaos. Massive structures appeared earlier than expected. Regions of space looked more organized than they should have been. And the data began asking a question that sounded almost forbidden. What if the cosmos was built around a deeper architecture? Not necessarily designed by intelligence, not necessarily artificial, but guided by hidden rules that our current physics has not yet fully described. For decades, cosmology has relied on a basic assumption. When you zoom out far enough, the universe should become smooth and statistically uniform. But James Webb is forcing scientists to look again. Because the early universe does not always look smooth. It looks active, it looks structured, it looks older than its age. The most shocking examples are the early galaxies. According to the standard timeline, the first few 100 million years after the Big Bang should have been messy and unfinished. Matter was still gathering. Stars were only beginning to ignite. Galaxies should have been small, faint, unstable, and chaotic. But Webb has found candidates that look brighter, heavier, and more mature than many models predicted. Some appear to contain enormous amounts of stellar mass. Some seem surprisingly well-formed. Some look as if they had more time to grow than the universe should have given them. And that single contradiction is shaking the foundation of modern cosmology. How did these galaxies form so quickly? One answer is that our measurements may need correction. Maybe dust is making some galaxies look brighter. Maybe distances are being misread. Maybe early stars formed faster than we believed. Maybe the first galaxies were more efficient, more violent, and more productive than our models allowed. That is the careful answer. But the uncomfortable answer is much stranger. What if the universe had a history before the history we can see?
What if the Big Bang was not the absolute beginning, but a transition? What if our universe is part of a cycle, expanding and cooling, then collapsing or transforming, carrying faint traces from one cosmic era into the next? In that case, these early galaxies might not be impossible. They might be inherited. They might be echoes. They might be signs that the beginning was not as clean as we imagined. This is where the James Webb story becomes more than astronomy. It becomes a question about memory.
Can the universe remember what came before? At first, that sounds like poetry, but physics has been struggling with the idea of information for decades. Quantum theory suggests information may never truly vanish. Black holes force scientists to ask what happens to information when matter disappears behind an event horizon. So here is the deeper question. If information cannot be destroyed, where does the universe store its past? Could it be hidden in gravity? Could it be written into dark matter? Could the largest structures in space be shaped by ancient imprints we cannot directly see? Dark matter is already one of the greatest mysteries in science. It does not glow. It does not reflect light. It does not behave like ordinary matter. But we know something is there because galaxies spin too fast, clusters hold together too strongly, and light bends where visible matter cannot explain the effect. We see dark matter by its consequences, and Webb is making those consequences harder to ignore. In some observations, light from distant galaxies bends around regions where no visible object seems massive enough to cause such distortion. The safe explanation is dark matter, hidden mass, invisible structure, a gravitational presence that affects light without revealing itself. But in certain cases, the distortion appears unusually concentrated, not like a loose cloud, more like an object, a shape, a silent mass sitting in the dark. And when space bends around something we cannot see, the imagination immediately wakes up. Could it be a dense dark matter clump? A black hole without a bright disk? A dead galaxy stripped of its stars? A remnant from an earlier cosmic age? Or could it be something even stranger? A structure so old it no longer shines. Something massive enough to warp space, but silent enough to hide from every normal telescope. To be clear, this is not proof of artificial construction. It is not proof of alien technology. It is not proof of anything beyond an unexplained gravitational effect. But that is exactly why it is so unsettling. A visible mystery can be studied. An invisible one can only be traced by the shadows it leaves behind. Then there is the strange perfection of gravitational rings. Einstein predicted that gravity could bend light. When a massive galaxy sits between Earth and a more distant object, its gravity curves space itself. The background light stretches around it, forming arcs, smears, and sometimes rings. This is known science. But some rings appear so clean, so balanced, and so close to complete that they feel almost unreal. For a ring of light to form, the alignment must be extraordinary. The distant galaxy, the foreground mass, and Earth must fall into a near-perfect line across billions of light years. Most of the time, the result is broken. A partial arc, a distorted curve, a glowing fragment. But when the ring becomes nearly complete, it looks like geometry carved into the sky. A circle drawn by gravity. A symbol written with light. Science can explain the mechanism, but explaining the mechanism does not erase the question. Why does the universe keep producing such precise forms? Why does the deepest chaos keep revealing mathematics? A ring is not a message, but it feels like one. And that feeling is exactly what makes the Webb discoveries so powerful. Each anomaly has a possible explanation. The early galaxies might be measurement errors or faster formation. The invisible masses might be dark matter. The rings might be rare alignments. The strange patterns might be chance. But together they begin to feel like interruptions in the same story. The telescope looks into the beginning and finds maturity. It looks into emptiness and finds mass. It looks at randomness and finds geometry. It looks at darkness and finds structure. And one by one, these discoveries pull us toward the same possibility. The universe may have rules we have not found yet. The cosmic web makes this even stranger. On the largest scales, galaxies are not scattered evenly. They gather along enormous filaments, like glowing threads stretched through space. Between them are vast, empty voids. Together, these filaments form the skeleton of the universe. This web is real. It is part of modern cosmology. But James Webb, combined with other observations, is helping reveal how early and how massive some of these structures may be. And that creates another problem. Gravity needs time. To build enormous structures, matter must pull on matter for millions and billions of years. Galaxies must gather, clusters must form, filaments must grow. But if massive structures appear too early, then something in the model is missing. Maybe gravity behaved differently in the early universe. Maybe dark matter formed patterns faster than expected. Maybe cosmic inflation left behind a hidden blueprint. Or maybe the universe was born with structure already inside it, a seed pattern, a deep geometry, an instruction set. If that is true, then galaxies did not form randomly. They formed along the lines of something older than themselves. Like iron filings arranging around an invisible magnetic field, matter may have followed a design written into space before the first star ever ignited. And if the universe was born with instructions, then the next question becomes unavoidable. Where did those instructions come from? This is where science touches philosophy. Careful scientists do not jump to design. They do not turn every strange observation into a cosmic conspiracy. They do not call every unexplained signal a message. And they are right not to. But caution is not the same as denial. Because the deeper Webb looks, the more it reminds us of a humbling truth. We do not observe the universe directly. We observe signals. Light that has traveled for billions of years. Light stretched by expansion. Light bent by gravity. Light filtered through dust, distance, instruments, and interpretation. Everything we know about the cosmos is reconstructed from ancient signals. And signals can be misunderstood. But signals can also carry meaning. That is why the most chilling possibility is not a galaxy, or a ring, or a hidden mass. It is rhythm. In the universe, many things pulse. Stars flare, pulsars rotate, black holes feed, explosions fade, galaxies flicker. Nature produces repetition everywhere. But imagine a pulse that does not fit. A faint flash from a region with no obvious source. A sequence too regular to dismiss, too brief to explain, too clean to comfortably classify. It appears, it repeats, then it vanishes. The first explanation would be technical. Check the instrument, check the processing, check for interference, cosmic rays, reflections, noise, and coincidence. That is how science protects itself from fantasy. But suppose the pattern survives every check. Then the question changes. Not what error created it, but what could have produced it. A hidden star, a compact object, a lensing effect, a physics process we do not yet understand, or something placed in the dark deliberately, not as a greeting, but as a marker. For decades, humans imagined extraterrestrial messages as radio signals, mathematical sequences, or obvious transmissions from another civilization. But what if a real cosmic message would not look like language? What if it would look like timing, a pulse in the dark, not loud, not dramatic, just precise enough to be noticed by a civilization that had finally learned how to look? In that case, James Webb would not simply be a telescope. It would be an ear pressed against the oldest wall in existence. And maybe, somewhere beyond that wall, something tapped back. This is not a conclusion. It is a possibility.
And possibilities are where every major discovery begins. There was a time when Earth was believed to be the center. There was a time when the Milky Way was thought to be the whole universe. There was a time when black holes were treated as mathematical ghosts.
There was a time when planets around other stars were only speculation. Again and again, humanity built a map. And again, the universe was larger than the map. James Webb may be doing that to us now. It may not be destroying science. It may be forcing science to grow. Because the real lesson is not that our theories are useless. The real lesson is that our theories are unfinished. The universe is not obligated to fit the limits of human expectation. It does not care how elegant our equations are. It does not care how confident our timelines feel. It simply exists, deeper and stranger than the story we wrote about it. And now Webb is showing us the places where that story begins to crack. Galaxies too early,
Mass without light, rings too perfect, filaments too vast, patterns too persistent, signals too precise. Maybe every one of these mysteries will eventually become ordinary. Maybe better data will explain the early galaxies. Maybe dark matter will solve the invisible mass. Maybe the rings will remain rare but natural. Maybe the pulses will turn out to be noise. That is possible. That is the careful answer. But there is another possibility, the one people whisper about and then quickly laugh away. What if the universe is not trying to hide its structure? What if the pattern has always been there? What if the only reason we missed it is because we never had eyes powerful enough to see it? The James Webb Space Telescope may be the first instrument that lets humanity glimpse the scale of that pattern. And if the pattern is real, then our place in the cosmos changes forever. We are not isolated observers on a small planet. We are late arrivals inside an ancient system, a system whose signals began moving toward us before Earth existed. A system whose structure may have guided the formation of galaxies, stars, planets, chemistry, life, and eventually, the minds now trying to understand it. Maybe intelligence is not an accident in the universe. Maybe intelligence is one of the ways the universe studies itself. Maybe every telescope is not just a machine pointed outward, but a sign that matter has learned to look back into the darkness it came from. And maybe the question is no longer whether we are alone. Maybe the question is whether the universe itself has been speaking in a language too large for us to hear. James Webb cannot answer that yet, but it has changed the question. We are no longer asking whether the universe is beautiful. We know it is. We are no longer asking whether the universe is vast. We know it is almost beyond imagination.
The question now is whether the universe is simply vast, or whether it is ordered in a way we have not understood. Are these strange discoveries only natural physics waiting to be explained? Or are they the first edges of a deeper structure written into reality itself? For now, there is no final answer. Only images, only data, only contradictions, only patterns waiting to be tested. But one thing is already clear. James Webb has done more than show us where the universe came from. It has shown us how little we truly know. And maybe that is the beginning of the next great human story. Not the story of finding one strange galaxy, not the story of detecting one mysterious signal, not even the story of discovering life on another world. The story may be far bigger. It may be the story of realizing that the universe itself is not what we thought it was, that the dark is structured, that gravity remembers, that light carries more than distance, that the past may still be written into the present, and that somewhere, hidden in the oldest corners of space, there may be a pattern we were always meant to find. So now the question is yours. Are these discoveries just the natural behavior of a universe too complex for our current science? Or are they the first signs that something deeper has been written into reality itself? Tell us what you believe. And if you want to keep exploring the cosmic mysteries that modern science is only beginning to uncover, subscribe, stay curious, and keep looking beyond the veil. Because the next image from James Webb may not simply show us another galaxy. It may show us the first clue that the universe has been waiting for us to learn how to see.